be open in Google Colab environment. So click on this file so that we can open it in our Google Colab environment. So here I am in my project 1 of Naïve Bayes Classification. So what we are going to learn in this project 1. So basically in this project 1, we will learn how to apply the Naïve Bayes classifier, and then we will also compare the performance of a Naïve Bayes classifier with the logistic regression. So in project 1, I need NumPy. I will import NumPy as NP. I need logistic regression. So therefore, I will import logistic regression from sklearn.linear_model, and I need a Naïve Bayes classifier. So I am importing Gaussian NB. So this is Gaussian Naïve Bayes classifier, and I am importing it from sklearn.Naïve Bayes. So we know that the Naïve Bayes classifier is a generative classifier, and it is always interested in order to know about the distribution of the data. So here it is assuming the data comes from the Gaussian. So therefore, we are using the Gaussian Naïve Bayes classifier. So let's run this cell to import all these necessary Python libraries. Now it's time to generate the data. So here I am generating a data having 12 samples only. Okay, so this is the same data set which we have already seen in the section of logistic regression. So we have the values in X. This X is our feature and this Y is our label. So we have two kinds of label. For first 6 samples, the label are 0, and for the last 6, it is 1. So what is meant by 0 label and what is meant by 1? So basically, this X is the feature value. Here in X, we have the size of the tumor. So this is the size of a tumor in patients, and based on the size, we assign the label 0 or 1. 0 means no cancer, and 1 means the patient has a cancer. So basically, we have the size of tumor, and based on the size of a tumor, we will decide whether the patient has a cancer or not. So we assign two labels, 0 means no cancer and 1 means cancer. Let's run this cell to generate the data. And here, if you see at the end of the feature, I have used dot reshape -1 into 1. That is to transform 1D data into 2D. Let's see the data here. So we can see that we have transformed this data into 2D, and now it is in the form of column. Okay, now for training, first we will train this data on the logistic regression classifier. Here I am instantiating the logistic regression classifier, and I am call this variable as logreg. Here I am fitting my logistic regression to my data set. That is, I am training the logistic regression classifier on the data. So here is the feature and here are the labels. Let's run this cell to train the model. Now get prediction from unseen value. Now we have to create a test data. Unseen value means this is our test data. So here test data, I am just creating the simplest form of the test data, that is only one sample. And here I am reshaping it like I did with the value of X. So this is our test data. So the first step is, after creating the test data, we are getting the probabilities of prediction of this test data from our model. Our model is LR. So the line of code is lr.predict_prob_a. So this will be able to find the probabilities about the class of the testing data. Let's run this cell. So we can see that our data belongs to a class 0. The reason is that the probability with class 0 is high as compared to class 1. So this is 0.54 and this is 0.45. So in this way, we have calculated the probabilities, or we get the probability prediction from the logistic regression classifier, and we see that the probability in favor of class 0 is high as compared to class 1. Okay, let's check the class prediction without the probability. So here we will use lr.predict on our testing data, and we can see that our prediction is in the favor of class 0. So according to the probability, it is in the favor of class 0, and if we get the direct predictions from our model, it is still in the favor of class 0. Class 0 means that the patient doesn't has a cancer. So patient doesn't have a cancer with the size of tumor equals to 3.5. Okay, now it's time to apply Naïve Bayes classifier. Now for the Naïve Bayes classifier, we are instantiating our Gaussian Naïve Bayes classifier, and I am calling it NP_model. And here I am fitting this model to my training data, that is X is the feature and Y are the labels. And here I am creating the test data again. And now I am getting the probabilities. So if I run this cell, the command for the probability is same. This time our model is NB underscore model, and we are using predict underscore prob A. If we see, still it is in the favor of class 0. So according to the Naïve Bayes classifier, the probability associated with the class 0 is high as compared to class 1. And if we get the predictions, we can see that the prediction is also in the favor of class 0. Okay, now let's compare the Naïve Bayes classifier with the logistic regression classifier. So if we see, their performance is equal in that sense that both have classified the test sample correctly and in the favor of class 0. But if we see the probability values, so it assigns the probability of 0.54 or 54% in the favor of class 0. And if we see the performance of Naïve Bayes classifier, it is assigning the probability of 0.8 or 80% to the class 0. That is, Naïve Bayes classifier is more sure about the probability of the class. So in that way, we can say that the Naïve Bayes classifier has performed better on this data as compared to the logistic regression. And if you remember, when we compare both those classifier, we know that the Naïve Bayes classifier is a generative classifier, and it has high bias and it performs well as compared to logistic regression if the size of the data is small. So we can see that here the size of the data is small. We have only 12 samples. So in that case, we can say that the performance of Naïve Bayes classifier is better than the logistic regression in that term that it assigns a highest value of probability to class 0 as compared to the logistic regression. That is, the Naïve Bayes classifier is more sure that the testing sample belongs to class 0 as compared to the logistic regression. So in this lecture, we learn how to apply the Naïve Bayes classifier. We see that we apply Gaussian Naïve Bayes classifier. The reason is that the Naïve Bayes classifier is a generative classifier and it is interested in order to know about the distribution of the data. So that's why we are using the Gaussian Naïve Bayes classifier. Then we compare the performance. We see that the data set was small in project 1, and in that case, the performance of Naïve Bayes classifier is slightly better than the performance of logistic regression in terms of identifying the class prediction or the probabilities of class prediction. So I hope you understood this project. Thanks for listening, and I will see you in the next lecture.